Hi everyone. Welcome to the course Mathematical Modeling. You may have some questions in your mind. Why do we learn these techniques? Is this important? Are there any applications, real world problems that can be applied these techniques? Hopefully you will have answers of some of your questions end of this video. Let me give an introduction first. Problems in optimization are the most important applications of mathematics. Everyone almost daily solves optimization problems in informal ways by using mental models. If you have ever looked at a map when planning a trip and decided upon a route to your destination to try to minimize either distance or time, you have solved an optimization problem. If you are a football player, you might want to maximize your running yards. So, what is the model? A model is a representation or an abstraction of a system or a process. Why do we use a model? We use a model to define our problems, then organize our thoughts, understand our data, next communicate and test that understanding. The finally make predictions. So now you see a model is a very important tool. What is mathematical modeling? First, we should think about where these math problems come from. As I mentioned before, these problems come from the real world. So we can tell mathematical modeling is the link between mathematics and the rest of the world. As examples, these problems could be from agriculture, astronomy, energy and transportation, computer science, arts, music, economic, engineering, or any area. So, let me summarize this. Think about real world problems. So, we can convert our real world problem to the real model by simplifying. Once we have a real model, we can get a mathematical model. Now think about mathematical model. So, what is the next step? Once we have a mathematical model, we try to solve it. And here also we calculate and give the conclusions. But most of mathematical models are very complicated. It is not easy to solve. If so, how do we solve these problems? Yes, we can write a program and make it computer model. You know, once we have a computer model, we can solve it. How do we solve the computer model? How do we get the conclusions? Yes, we should do the simulation process. Computer model, simulate and give a conclusion. Then finally interpret. So this is a circle of mathematical modeling. So in this semester you are going to learn about these steps and you are going to learn how to solve these real world problems and how to convert real world problem to real model, then mathematical model, and especially how to solve them. Yes, you will learn some computer techniques also. So hopefully you have some idea what we are going to do about. and what is mathematical model. Now let me explain a little bit about our course. This course will cover both spectrum of modeling problems, from optimization to dynamical systems to stochastic process. You will need knowledge of calculus and all of mathematics as well. As an example, for the first few chapters, we are going to talk about maximization and minimization. So you should know how to use the calculus to solve maximization and minimization problems. You know the derivatives. How do we find the maximum point or minimum point of a function? Get the derivative of the function and set that equal to 0 and solve for the variable, normally x. So same thing we are going to do in the chapter 1 and from chapter 1 to chapter 3. Therefore, if you cannot remember, please go back to your calculus note and refresh your memory. This course is organized into 3 parts. Yes, according to book, we begin with optimization models. Then we are going to talk about dynamical models, and last few chapters will be on probability models. And also each chapter of the book we use is followed by a set of challenging exercises. These are real problems. These exercises require significant effort as well as a certain amount of creativity on the part of the student in your side. So I hope you have some idea about the course and what we are going to do. So still, if you have any question, just email me. In my next video, I am going to explain chapter 1, one variable optimization problems. I wish you all the best. Good luck.